My dear students, I am very happy to see you today. Today, we will get the important lesson. Sure, we must say the important. Do you know why? Because it's our target to get a full mark. So, today we will start for chemical analysis. This is about Unit 2. Are you ready to understand it? Sure. The lesson will be we have thio. Thio what? Thiosulfate. What is the formula? S2O3 all negative 2. We have 3 S. Sulfite, sulfide, thiosulfate. Thio, we have oxygen here for its reaction, can be, as you see, good primary test. What's it mean? Sodium thiosulfate, Na2S2O3. Yes, I'm sure. React with, good, my dear. I hear good answer by HCl. 2 molecules give me, look at this. Sodium chloride, we know 2NaCl. Only? No, we have a water, sure. And we have, look, SO2. Do you know what this means? Oh, we know it. Sulfur dioxide, which has irritating smell. It's back again. Look at this reaction. Sulfur dioxide, yes. The yellow PPT as result of suspended sulfur in its solution. Here you have a S, you have a sulfur. So the reaction will be, so get this reaction now, Na2S2O3, good, plus what now? Plus 2HCl, 2 molecule for its aqueous. Give me what? Give me salt, 2NaCl, plus what? Plus water, plus what? SO2, plus S. S, yes, this is the yellow precipitate which is suspended for this solution. Good reaction. Salt solution here. When I get it with iodine, oh, iodine solution, this other reaction. Yes, do you remember what this means? Good. It's a confirmatory test. We learn it now. You are a good student. The brown color of the iodine is removed. Oh, what happened? Na2S2O3, thiosulfate of the sodium. What happened now? I2, aqueous solution. To give what? To give Na2S4O6 only? No, we have 2NaI. Yeah, NaI. Do you remember what this means? Make exchange it. Good. Sodium iodide. My dear, sodium tetrathiocyanate, Na2S4O6. Oh, it's long. Yes, I'm sure. It's more. Nitrite group. Nitrite group here, it means NO2, all negative 1. Its valency is what? Its valency 1. The reaction can be NaNO2, sodium nitrite. Sodium is our metal. Yeah, we know it by primary test. You add HCl. Now, do you think what is the result here? We have a salt. Yes, we have a salt. This salt will add it to the end. HNO2 is formed. Yes, nitrous acid. Also, water. Oh, HNO2, here is a nitrous, will be decomposed into HNO3 plus what? Plus water. It's good to say NO. What this means? NO, it means colorless gas. This colorless gas, when it's exposed to the air, it turns into what? Reddish brown. Do you remember what this reddish brown? This reddish brown gas, it means nitrogen dioxide. Yes, from NO to NO2 at the mouth of the tube. 2NO plus more of the oxygen give me 2NO2. What this mean? Reddish brown gas. It's very important to understand all of them. Salt solution, I know it, plus what? Plus potassium permanganate. This is what? Confirmatory test. Now, acidified by concentrated sulfuric acid, the violet color of potassium permanganate disappear, removed. Its color is a violet. When you add to the salt, disappears the color. Let's see the reaction can be how. 5NaNO2 sodium nitrite added to potassium permanganate 2KMNO4 in its aqueous, added to sulfuric acid to be acidic medium. Not in a medium, acidic, not a basic. What happened now? Give me NaNO3 sodium nitrate, only no potassium sulfate K2SO4 and MnSO4 permanganate. Here is for manganese, good, manganese sulfate, potassium sulfate, all of them are formed for this reaction. You add important one, yes, it's water, molecule of the water will be evolved. Now, what is the color? Nothing. The color of KMNO4 is disappeared. Why? Due to formation of K2SO4, also to MnSO4 for its aqueous solution. My dear, my lovely students, you catch now the first group. The first group, HCl. HCl has a what and what and what? Has carbonate, bicarbonate, sulfite, sulfide, and thiosulfate at the end, nitrite. Don't forget, these anions only work with what? With HCl. Concentrate for them, because all of them give that what? Important gas. So catch this gas and catch its color. Concentrated sulfuric acid, this is group, yes, group number 2. This group including the following anions. Do you think what these anions? Look, my dear, you have chloride, yes, Cl, negative. It means its valency is a what? -1. Look at this, gain 1 electron. Bromide, it means Br negative. What else? Iodide, I am sure. Chlorine, bromine, iodine, I -1. Do you remember what this means? This is special group for halogens. If you remember, group 7A, fluorine, chlorine, bromine, iodine. What? It's anion. Fluoride, but this is not for our us. Chloride, this is work. Bromide, it's a follow it. Iodide, the last one. This group also contains a special group for nitrate. For HCl, nitrite. But here we have a what? Nitrate. What its symbol? Yes, good. Formula NO3, -1. Be sure all of this group, -1. Now, what about to start reaction? The reaction can be detected based on the concentrated sulfuric acid is more stable, yes, than the acid formed which is these anions. More stable, yes. When I ask you why we use sulfuric acid, because it's more stable than the formed acid. Look at this. These anions are derived on adding concentrated hot sulfuric acid. HCl gas is evolved, which is what? Colorless. It gives white fumes when the glass with ammonia solution is passed. Do you know what this means? Detecting Cl negative. Chlorine, very important to say that. Look, my dear, anion, chloride. Cl what? Cl negative. What you have? HCl gas. Hydrogen chloride gas is evolved. Don't say hydrochloric acid. It's wrong, because I work through the gases now, which is a colorless and give white fumes when glassed wet with ammonia solution is based on this gas. Let's see for this. When I give you for the first one anion reaction to NaCl plus H2SO4, yes, H2SO4. My dear, take care. Sodium is constant. All of them in A? Yeah, all of them in A. But here I have a strong acid, HCl, H2SO4, more stronger than HCl. Look here, by heating, it's heating and concentrated. Give me sodium sulfate plus the important gas. You remember this gas? This gas HCl. The HCl, when it's passed on ammonia solution, will give us what? HCl plus ammonia NH3, give me the gas here NH4Cl. Yes, it's important. This white clouds, this the important reaction for the first one. This only, I'm sure it's not this. You have confirmatory test? Yes, I have confirmatory test. You remember when I get the salt solution and add what? Add here silver nitrate. Concentrate for the reaction. The important one for this reaction for confirmatory, AgNO3. What happened for this reaction? Why it is formed? Why BBT is formed? Silver chloride, which turn what? Violet. Violet in the sunlight, soluble in concentrated ammonia solution. What about to get this reaction? NaCl for its aqueous solution is added to AgNO3 for its aqueous solution. Now, you remember when I said before this double substitution reaction. Make exchange now, AgCl plus what? Plus NaNO3. Be sure AgCl here is white precipitate. My dear, when I get the other one, bromide, Br negative, the reaction here give me HBr. Sure, all of this group will be acid, but weak one. HBr gas is evolved, which is what? Colorless. It's partially oxidized by sulfuric acid. Catch the reaction now. You have bromide, Br negative. Now, orange red fumes from what? From bromine will be separated. Take care for the color of Br. Color here is what? Is red color. Turn the paper wetted by starch into what? Into yellow. What about the reaction now? The reaction can be Br negative. The first, sodium. Sodium, yes, we know. We fix the sodium as a metal, as a positive, to NaBr plus what? Plus here, sulfuric acid. This reaction, very important. In presence of heat, a hot concentrated acid, give me sodium sulfate. Only, no, the gas evolved here, which has an acidic effect to HBr, hydrogen bromide. Hydrogen bromide, this gas has no color, this primary test. What you do here? I can say 2HBr plus sulfuric acid, hot concentrated sulfuric acid, give me water plus what? SO2 plus what? Plus Br2, this is special one. My dear, Br2, it means bromine gas is evolved for this case. My darling, what about to get confirmatory test? Confirmatory, yes, it means I want to be sure this is Br or no. You have a what? Salt solution. And what else? Silver nitrate. Exchange. White, yellow BBT is formed. Yellow, white, yes, I know. This is from AgBr, silver bromide. This silver bromide turns to dark in the sunlight. Soluble, yes, but soluble slowly in ammonia, concentrated ammonia. Look at this. When I say NBr plus what? AgNO3, double substitution. Now, what you have? AgBr plus what? Plus NaNO3. It's good to say that. You must know iodide. I, it means iodide. What happened? HI gas is evolved. Also, yeah, but it's colorless, is partially oxidized in presence of sulfuric acid and the violet fumes from iodine. Will be what? Separated after heating. Turn a paper with what? With starch into blue. The color change? Yes, is it changed? What the reaction can be now? Potassium iodide, silver nitrate. What happened now? AgBr, good, plus NaNO3. My dear, what about when I get HI, this colorless gas, and I add more of sulfuric acid? Do you think the reaction stay? No, the reaction will be new one. You have a water. What? SO2, irritating smell, if you remembered. Also, when you get a conformatory test by salt solution and add silver nitrate, do you think what happened for this reaction? Yellow BBT is formed. This from what? From silver iodide, which insoluble in ammonia solution. Not soluble, insoluble. My dear, NaI plus what? AgNO3, double substitution, give me AgI plus NaNO3 is very important. My dear students, from all of this reaction, it means chlorine, bromine, iodine. This group, back to halogens for group 7A, you must know important thing. All of them give colorless gas of acidic effect. Chlorine give HCl, bromine HBr, iodine HI. So these different gases, the important test for them for this group. Concentrate. Without this reaction, can't understand the gases. Which is the color is a change? Yeah, the color is a change that we need it. What you need? I need the color for this gas. Concentrate. Nitrate. NO3 -1. Chemical test for nitrate. Now you have the salt for NO3 negative. Has a nitrogen with 1, 2, 3 bonds of oxygen by the fixed angle 120. Now, I say this radical is a constant. Its valency is what? -1. I have ammonium nitrate, sodium nitrate, potassium nitrate. All of them can be found on a sponge in regular, in different compound crops. My dear, when I get sulfuric acid here, and I try to make primary test and the confirmatory test. Primary test can be by heating, yes, or concentrated acid test. This is two important one. Confirmatory, diphenylamine, this is other test, or by the copper and so on. Now, the material that needed for nitrate salt, FeSO4, hold different test tubes, and we have flame. What about our procedures? As a beginning, get test tube as a salt, and I try to heat it. Well, I heat it on the flame. Oh, you see the gas? What happened? I have NO2 gases evolved. Lead, nitrate, sodium nitrate, anything, give me a special gas. What this gas? NO2 reddish brown gas. When you add FeSO4, you see, where is the color? You see it's a black ring. Sulfuric acid. Sulfuric acid, yeah, material needed for this. We have originally the salt holder, we have a sulfuric acid, I get FeSO4. Now, what happened? When I get this pipette and start for procedures, we can say for this reaction, get a test tube which has our salt. Add drops of what? Of sulfuric acid. KNO3 plus sulfuric acid, KHSO4 plus HNO3, nitric acid. Nitric acid here is not a stop. Look, the color here, when you add this paper, it changes into, good, reddish brown. Yes, it changed. Do you think what happened? We have also NO2 gas. Yes, you must know the important gas, especially for nitrate, it means what? NO2. Add more of FeSO4, you see FeSO4 gave me the other black ring. Confirmatory test for diphenylamine test. It means I have a copper chips, I have brown ring. Now let's see the first one. Get the materials for a special reaction. Salt solution, diphenylamine. Now, this is the same material. What about procedures? I get here the salt solution as you learn it, and I add drops of diphenylamine. You see, yeah, the color is changed into what? Into blue. It means I have nitrate salt. What about the copper chips? When you get the materials, the same salt, the same sulfuric acid, and here I have a copper chips, pieces of the copper. Now, get the reaction. I know we have a flame. Procedure here, yes, procedure. Get the salt, and I start to add drops of sulfuric acid. Concentrate and look. I add it smooth, slowly to give me HNO3, nitric acid. How can I know? When I add the copper and start to be heated, you see reddish brown gas is formed. It means NO2 is formed. Very important test. Brown ring, I have a brown ring, and important one. When you get the same salt solution by the holder, FeSO4, it means I2 sulfate and the drops of sulfuric acid. Now, what about procedures? You can say the salt solution has drops of this acid slowly as you learn it and as you see FeSO4, and adds smooth and slowly drops of sulfuric acid. Concentrate. The reaction start to be happen and form, good, FeSO4 plus H2SO4 plus 2HNO3. You see, will be, yes, good. This is brown ring. You see the brown ring? Important for us. Now, you can say, handle apparatus of the chemical carefully and use drops of the reagent of the bottle of FeSO4. Now, clear lab, clear your coat and your gloves performing this experiment. Catch now, from the experiments which we saw it before, the brown vapor of the nitrogen dioxide evolved due to what? Due to decomposition of the nitric acid, HNO3. The density of the vapor increased. Increased by what? It's increased by adding copper filling. You see, 2NaNO3 plus our sulfuric acid conc hot to give me Na2SO4 plus good nitric acid. Now, I get this nitric acid. Yes, by heating, I'm sure. You must know strong oxidizing agent. What happened? Give me water plus what? Plus NO2. This is our target. NO2 is our gas. What its color? Reddish brown gas. At the same time, give me O2 gas, oxygen gas. So this reaction will be strongly 1. My darling, when you get HNO3 for HNO3 and you add the pieces of the copper for this reaction, look, copper nitrate is formed plus water plus NO2. I know this is our gas. What its color? Reddish brown gas. It's good to say that. Brown test ring, I know, and we saw it for the movie. You remember when I said for this, nitrate salts, this is confirmatory 1. Plus what? Plus freshly prepared solution. Must be freshly prepared, yes, not for the old, not left for many days, to help the reaction to be fast. And iron 2 sulfate, it means FeSO4. You add drops of sulfuric acid slowly as we saw it before. Now, when I make this reaction, 2NO, I know this acid reactant solution disappear by heat or shaking. What you want? I say 2NaNO3. When it added to FeSO4, give me what? Plus what? Plus sulfuric acid, hot and conk. Give Na2SO4, I'm sure. Give also FeSO4 at the same time water, and the ring starts to be formed. FeSO4 plus NO. What this mean? Brown ring, my darling. This is when it added, give me FeSO4 dot NO. This what? The compound of brown ring. When I ask you what this compound, it means NO, yeah, 1 molecule. FeSO4, 1 molecule. It's good and important. We arrived to the end of the lesson. Do you think you understand it? I think so. Study it well to get a full mark. I'm waiting you to tell me your opinion about the lesson. My dear, see you soon. Thank you and goodbye.